talking, and this looks like arithmetic. It's not arithmetic, it's arithmetic, okay? So these are arithmetic sequences. These are not hard. These are not hard.
I don't remember these.
They're not bad, I promise. Okay, so here's the deal. You ready?
Yeah, I'm ready. I was born ready.
You were born ready. Okay, let's do this.
Wait.
We are talking sequences here, okay? We're talking something, some order to things. What you need to know is when they talk about... nope, I'm not going to do that. Let's do this. If I give you this setup. Oh, I didn't move it over. Sorry.
You're good.
Thank you.
HDMI. What is
How did they use it?
Pretty good.
Oh. Just get up and leave. Yeah.
This class is really good.
Really what?
Loud.
No. Who's peeing right now? Here it is. Can I teach a lesson?
Yes.
That'd be great. Let me teach a lesson. What you're going to do with arithmetic sequences is you're going to look at a set of numbers and figure out what pattern you're seeing with it. So our first example here, you're going to describe the pattern and then figure out what the next two terms would be. So if I give you these numbers, so we're going to start with 5, and then 8, and then 11, and then 14, and then ... What we're looking for is what's the pattern? What's happening?
They're going by threes.
How by threes? You're multiplying by 3, you're adding 3,
adding.
you're adding 3. Okay, so here's the pattern, right? We are going plus 3, plus 3, plus 3 to get to the next one each time. Okay, so when they ask you what is the pattern, this pen doesn't like me right now. When they ask you for the pattern, you just say the pattern is plus 3. Okay? When they ask you for the next two terms, when they say terms, they're asking for the next number that would come. Okay, so this is a term. This is a term. This is a term. This is a term. So this is our first term, our second term, our third term, our fourth term. We're looking for what are our fifth and sixth terms right now. So the next two numbers that you would get if you kept following this pattern. What would come after 14? 17. And what would come after 17? 20. Okay, so they're going to ask you for the pattern and the next two terms. That's what you're giving. Questions on that?
No.
Okay, what about this one?
Ooh, that's it. Wait, is that it?
No.
Oh no.
All right, 2.5. Sorry, my pen doesn't want to write decimals right now. 2.5, 5, 10, 20. How am I getting to my next term each time? What's happening to the number?
Times 2.
Times 2, right? So 2.5 times 2, 5 times 2, 10 times 2. Each time you're multiplying by 2. So when they ask for the pattern, you're just going to say times 2. And then the next two terms, that's what you're going to do. You're going to multiply by 2. So what would come next?
40.
40. 20 times 2. Okay. And then what would come after that? 80. 40 times 2 is 80. Okay. So find the pattern, find the next two terms. Questions on that? No, we're not done.
Is that on the
Worse.
Oh my word, guys, I'm going to teach you the rest of it. Just watch. You'll see what else is coming. You will see. You're killing me right now. All right. when something is the word that was at the top, arithmetic. Ugh,
What is going on?
my app is messing up these days.
That's tough.
Yeah. It's just messy. When something is arithmetic, when you think of arithmetic, what does that make you think of? Math. Okay. Any particular part of math? Addition. Okay. Geometry. So when there is an arithmetic sequence, that means you are adding or subtracting. You could say adding or adding a negative. Basically, the difference between your numbers is constant. So you are going up by adding the same thing. So if I have to add the same thing, is this an arithmetic sequence?
Yes.
Yes. Is this an arithmetic sequence?
No.
No, because we multiplied, right? So if you can add to get to your next thing, and technically adding a negative, which is going to look like subtraction, still adding, right? You could add a negative and it's going to go down. So adding or subtracting, you could look at it as being arithmetic. So I want to know, do you want a definition for arithmetic here? Let's see. The difference is constant, also known as you add to get the next term. Okay, so if you can add to get to the next term, the same thing every time, then you have an arithmetic sequence. All right, so here's what I want to know on this one. If I give you, for example, 2 here, a set of numbers, and I ask, is it arithmetic? Okay. If yes, find the common difference. Is it arithmetic? And if it is, you're going to find the common difference. So I'm going to give you a set of numbers like 3, 8, 13, and 18. Okay, looking at that set of numbers, would you say it is arithmetic?
No.
Why not?
But yes, actually,
Why?
it goes up by 5.
It goes up by 5 every time, right? We are adding 5 to get to our next number every time. So the question is it arithmetic? Your answer is yes, because you are adding 5 each time, okay? That means my common difference, which we'll just call it CD for now, okay? My common difference. In other words, the amount I'm adding each time is a positive 5. Okay, so my common difference is 5, and it is arithmetic. How about this one? If I give you 6, 9, 14, that's not what I meant to do. Whatever, it doesn't matter. Let's say I give you this set of numbers, 6, 9, 14, 17. Is that arithmetic?
No.
Why not?
Because it doesn't go up the same number.
Right, this is plus 3. This is plus 5. This is plus 3, right? So is it arithmetic? The answer is no. And if the answer is no, there is no common difference, right? So you can't answer with a common difference. Okay? You boys with me over there? Okay, questions on that? Okay, here's where you're gonna get a formula. And this formula looks a little intimidating. I promise you it is the same thing every single time. You just have to figure out what goes into that place. So write this down in your notes and use it as you do your homework. It is not as bad as it seems.
Is this the one where it's like a question would say like find the 10th term?
Yes.
No.
This is so easy. It's so easy.
Work.
It's so easy.
What do you guys do? No. You're not even.
Okay, here is the formula. Excuse me. Here is the formula. You have to figure out the pieces that go into this formula. And it looks overwhelming because there's a lot of letters going on. But I will tell you right now, it is not as overwhelming as it looks, okay? This right here, A of 1. Sassy. A of 1, okay, is your first term. So for instance, if I look back to this problem, A of 1 would have been 6. If I looked back to this problem, A of 1 would have been 3. Okay, your first term always goes right here. Don't let the A and the 1 freak you out. Just know it is your first term, A of 1. Okay? This is whatever term number you are solving for. Okay, so this number and this number are both your term number. So say I want to know the 5th term in the sequence. I would plug in a 5 in both of those places. Say I want to know the 100th term of the sequence. I would plug in a 100 in both of those places. Okay? And then the last thing in the formula is this D, and that's your common difference. Okay, and we already learned what the common difference is. The common difference is whatever number it's changing by each time. So whatever you're adding to get to the next term, that's your common difference. Okay? So what we're going to do is I'm going to give you a setup here. You're going to come up with the formula, and then you're going to find the 50th term or the 100th term or the 8 millionth term. And we won't go that high. But the whole point of this formula is so that you don't have to do so much work. This formula does the work for you, okay? So here's the problem, and then we will go through any questions you have with it. Okay, so example 4 here. It says, write an explicit formula to represent the bids from an auction as an arithmetic sequence. What is the 12th term? So here are your bids, okay? Bid number 1 was $200. Then the second bidder, bid number 2, bid $210. Okay, the third bidder bid $220. And the fourth bidder bid, any guesses? $230. Okay. So this is your setup. Your job is to figure out your arithmetic sequence so that you could find what the 80th bid would have been. Okay. Rather than have to go through 80 numbers the whole way through, you can plug in one number and solve it. Okay. So if this is my setup, you can kind of think of it as a T-chart if you want. So this is the term number, and this is the bid amount. So our first bid, whoa, just got dark, was 200. Our second bid was 210. Our third bid was 220. And our fourth bid was 230, okay? You don't have to do the T-chart because this is essentially giving you that same information, but if you like to see it in a T-chart, you may do it like that, okay? Here's the deal. We are trying to set up a formula for this. So our formula, this is just the generic formula again. You already have this written down, but I want to show you where I'm going to plug things in. So I'm going to write it like this again. Okay? Can you tell me what should go here? The 200, right? We said this was our first term, and if you look up here, my first term is 200. So when you rewrite this, you're going to rewrite it A of n equals 200 plus n minus 1, because we don't know our term number yet. We're still trying to come up with just the regular formula. What's the common difference in this problem? 10, right? Each time you were going up by 10. Plus 10, plus 10, plus 10. So my common difference is that number. So we're going to put times 10 right behind that. Okay? So if they ask you for the explicit formula, this is it. Now the question said, what is the 12th term? So if I want to know the 12th term in this setup, what do I do with that?
Put 12 where the first one is, and then you put it where the minus 1 is.
Right, you're going to plug in a 12 in two places. You're going to take that 12 and you're going to put it in for your ends. Shoot. We're done. This was the end of it. But you would do a of 12 equals 200 plus, listen, don't pack up, just listen. Right? This is your setup. So you're going to do 11 times 10 plus 200. Make sure you do this first. So 110. Excuse me. Did you hear me say don't pack up, just wait? Yeah. Plus 200. And then when you solve that, 200 plus 110 is 310. So your 12th term would have been 310. Okay?
Okay.
Now